Our first guest is going to knock you out. Eddie Goldstein. Please join us, Eddie. Come on in.
Okay. I came all the way from Boulder, Colorado to New York City. I want to hear some New York energy. That is what I like. But who knows where that energy comes from? Shout it out. The moon. No.
There's a new one.
Sugar, I'll tell you. Actually, there is one place where virtually all of the energy that is on planet Earth comes from, and it is the sun. That's right, the sun. But the problem is, you need energy all the time. Not good enough just to have energy when the sun comes out. Like you're walking along and the sun goes down and then the sun comes back up and you're feeling good and you go inside a club to do a little bit of dancing, no sunlight, and somehow you need to be able to store energy. And that's what really got me interested, how you could store energy. And that's what I want to tell you guys about. Different ways you can store energy, different ways that planet Earth stores the energy of the sun, and most important of all, how it stores the energy of life. So you ready to go? All right. Because I brought some cool stuff with me that I want to show you. Here I have an electrical generator. Now, I've got a lot of energy stored in my body right now, and a little bit later on you're going to be hearing about how that happens. But I can use some of my energy to crank this crank and light that light. There you go. The problem is that when I stop, the light goes out. So I need a way to store energy so I can use it later. And I came up with this thing. It is a flywheel. I mean, I didn't invent it, but I came up with this idea to show you. A flywheel, basically it's just a heavy tire. And I'm going to crank it. I just put energy into that system. Right now, there is stored energy in the motion of that flywheel. That boggled my mind. I didn't realize that you could store energy with motion, and you can. Typically, it's slowing down a little bit.
Yeah, why is it slowing down now?
Well,
it's friction?
There's friction over here. If this were totally frictionless, it would go on forever without slowing down at all. But some of the energy is being turned into heat. If I were to touch that right now, it would be hot. And so I'm not...
So that's an example of what I was talking about before, that the kids get so well. That energy, it can't be destroyed. It just gets transformed into something else. Huh? So now this motion, we see the energy as motion when the wheel is spinning.
Yes.
And then it turns into heat because of friction.
And that's exactly right. A little bit of it turns into heat. Let me get it cranked up again, because I want to show you a different way that I can tap into the energy that is stored in that flywheel. I'm going to slide my generator in and have that flywheel turn the crank. And it lights the light. I took energy from there over to here, and that's why this slowed down so quickly, because I lost energy and I brought it over here. How many people are following what I'm saying with that? Okay, this is awesome.
Let me just make sure I follow you.
Okay. And you're not 11 years old anymore, so this is going to be tough.
So the thing that gets me about energy is you can't see it, you can't imagine it. You only know it's there when it does something and something else. Like you know it's there if you feel the heat, or you know it's there if you see the motion.
That is very perceptive observation.
It does work of some kind, and you don't know it's there until it does the work.
That's right. And so the only way that we know that energy is there is trying to use it to light some bulbs or do any sort of kinds of work.
And you use it from taking it from some place where you're noticing it's happening. Or maybe you don't even notice it, right?
And you store it by putting it into a form where it will remain for a long time, and then you tap it out later.
Gotcha. Now I got it.
Okay. Well, here's the really amazing part, is that planet Earth stores energy the same way. It stores energy with motion, and here is how. I want you to imagine that the sun is shining down on the earth, and some places it gets hotter than other places, like the land during the daytime gets hotter than the water. Well, since hot air rises, the place over the hot spots rise, that air rises, and so other air has to rush in to fill the space. That's what causes wind. That circular motion that you see is really just the energy of the sun stored as the motion of the wind. It's just like that flywheel. It's very interesting. People have been tapping into the energy of the wind for hundreds and hundreds of years. Think about it. Those giant sailing ships that you saw way back when, where people explored the entire planet, that was using the energy of the sun, which comes from the wind. Or they invented windmills. Windmills take that energy of the wind, spin the windmill, that will turn machines, and those machines can be used to grind grain into flour, all sorts of cool stuff like that. Today, there are large wind farms which take the energy of the wind, spin those propellers, which spin electrical generators, and actually right now in the United States, 5.5% of the energy, electrical energy that is produced comes from wind energy. So it got me thinking, how else is it that the earth can store the energy of the sun? And so I have another little something to show you. This is pretty cool.
I think this is going to be what I was trying to find out before. Sometimes you don't see the form of energy that you don't see what has been transformed into because it's not moving. It's still, I bet.
It's like you can't see the wind other than when you see the leaves
You see
rustling or something
what
like
it
that.
does. Yeah.
Yes.
Yeah, go ahead.
So I want to break this board, and I have with me a 3-pound sledgehammer. If I just lay the sledgehammer on the board, that's not enough energy to break the board. So I'm going to add energy in order to break the board. And I have to put on my safety equipment. How many of you folks out there are either scientists or might want to be scientists one of these days? A lot of people. One thing I want to tell you, if you're doing scientific experiments, always safety first. That's the most important thing. So
And
don't
it looks
forget
so
that.
good, too, doesn't it?
Huh? Looks good?
Great.
Okay, here we go. There is the board. Here is the hammer. I'm going to add a little of my own energy.
Whoa, fantastic. Bravo. Whoa. Whoa. Really good.
Impressive, isn't it? Okay. Well, here's the deal. Is there a way to store energy for me to use later to break the board like that? Let me just pop that over there. And I came up with like a really cool way to do it using that ladder.
You're going to break the wood with that ladder.
I have the board over here. I'm going to place it right underneath the little gizmo I have at the top of the ladder. And now let me climb up. Now, that was called kinetic energy, the energy of motion. This is called potential energy. And when I climb up the ladder, it's harder for me to climb up the ladder because I'm lugging this hammer.
And you're going against gravity the whole time. You're working against gravity.
And that work against gravity that I am doing, that is the energy that I am putting into the height of the hammer.
So now that has the potential of having so much more energy because you brought it up so far away and high, and the gravity's going to be pulling it down to the wood.
That is right. And just as you were saying before, there's nothing to see. You can't see the energy until it does something, until it does some work.
But it has the potential of having all that energy when it gets a chance to do something.
By the way, that's a 3-pound hammer, and I raised it 10 feet, so that's 30 foot-pounds of energy that I put in there. The hammer's over there. Let's see if that extra energy is enough to break the wood. Here we go, little countdown. 3, 2, 1.
Whoa!
Now, here's the deal. I put in the energy to do that. It's just that I stored it temporarily while I was climbing the ladder. But the energy still was stored in my body, and I put it in there, and it broke that ladder. Okay, one more type of energy, and in a lot of ways, this next kind of energy is the most important, at least the most important for life on the planet Earth, because it takes the energy of the sun, captured by plants, stored in molecules, and is the energy for just about every life form on Earth. It is called photosynthesis. Green leaves are the main place that you see photosynthesis on Earth. And I want to explain what it's all about. Chemical energy is what it's called. But I'm going to do that first by doing a little bit of an analogy, another little experiment. Okay, I've got this beach ball. Let me move this. And this beach ball will stay exactly where it is forever unless I add some energy to the system. So I've got a little bit of energy stored in my body. I'm going to add it to the beach ball.
All right.
And,
I'm picking it up with a certain
Little
amount
help,
of it.
little help.
Oh, excuse me.
Okay, well, I
Thank
think
you
that
very
was,
much.
that was,
Look
should
at
we
that
give him
energy.
another shot over there? You're going to
Yeah.
get another chance.
Yeah,
You're going to get another chance. So I wanted to see, is there a way for me to store the energy so that I can like put the energy in and then store it and use that to knock that over? And I came up with this little gizmo, which is a pole with a bunch of magnets.
Those rings are magnets.
Yes. And you know, magnets can either be in attract mode or repel. These sort of repel each other like that. But I am going to put energy into the system just as I did before. So I'm squeezing.
So that effort you're putting into that is energy that's keeping them together, pushing them together.
And what's keeping it together is I'm clamping it over here with my hand. It wants to try to push it apart.
Yeah.
So there's energy stored here, just the same way as there was energy stored there, just the same way as there was energy stored with that. And if I were to release it, I get that energy back. So let me show you how I can use that to store some energy. And now release the energy. 1, 2, 3. Huh, nice.
Amazing.
Right over here.
What is it with this? I don't. It always curves out like that. What do you call it? It's a little wind energy. in
Yeah,
here.
that was exactly. Wind energy. But here's the deal with the energy. And this is the thing to understand. When I put energy in, this configuration of the magnets is storing a lot of energy. And then when I go like that, I release the energy, I get it back. How many people understand that when I say that? I'm storing energy in this configuration and getting the energy back when it goes into that configuration. It's still the same magnets. That's what has to do with photosynthesis. It might not be obvious, but I want to show you a little picture. I want you to imagine, instead of these magnets, atoms, because just the same way as magnets push and pull on each other, atoms can push and pull on each other. And if you look at the bottom half of that picture, there are 6 black balls. Those are carbon atoms. There are 12 white balls. Those are hydrogen atoms. And there are 18 red balls. Those are oxygen. The way that they are
Now, those balls,
arranged...
pardon me, those balls are all joined together in separate molecules, each figure of those balls, like the red, black, red, that's a molecule?
Red, black, red is carbon dioxide, 1 carbon and 2 oxygens. So that's CO2.
Okay.
And let me ask you, Alan, red, an oxygen with 2 hydrogens, H2O.
Oh, H2O, water.
Water, there we go.
Whoa,
H2O.
I'm a
is what-
chemist.
That is great. So, when you have that arrangement of those atoms on the bottom, that's in the lower energy. If you were to take those same exact atoms and rearrange them and squeeze them together into that tightly packed molecule that you see on the top, that tightly packed molecule is glucose, it is sugar. And sugar and what's left over are oxygen. So if you were able to add energy to the system, you could change the carbon dioxide and hydrogen and water into sugar plus oxygen. And plants can do that with photosynthesis. They take the energy of the sun to squeeze those molecules, squeeze those atoms into that different arrangement. Now, if I want to get that energy back, just like I got the energy back over here, it's easy. I take some of that glucose, some of that sugar, I add oxygen, and then I recombine all of those to get water and carbon dioxide again, plus energy. So how do you use something like that?
Yeah, how would that work in real life?
In real life, that's what I'm going to show you. Here I have an apple. You know, a lot of times, the sun will beat down on an apple tree over the course of months and store in here the energy of the sun in arrangements of molecules that form this apple. It's not just that glucose, but the glucose is used to make more complicated molecules as well. So there's a lot of energy stored in here. How do I get that energy back? Well, I take a bite of the apple. I breathe in a little bit of oxygen. And now I have all of the parts of my body to decompose that, give me the energy so I can have little energy to work with, and out I breathe carbon dioxide. So it's exactly the same thing that we were just talking about. Okay, that's like a couple of months worth of energy. Here I have a log. This log from a piece of tree, the same thing. It was the energy of the sun that was used to take that carbon dioxide and water and form the molecules of this wood. This is stored energy of the sun. When I want to release this energy, same as before. You take in oxygen, you need oxygen for any sort of burning, burn the log, and out comes a lot of energy, but also out comes carbon dioxide and water vapor. Any person who has ever used a fire to cook their food, a fire to stay warm, has basically used the energy of the sun stored over years and released that energy, but also released some carbon dioxide into the atmosphere. Not so much of a problem. This next thing, though, is really a two-sided coin. This is a piece of coal. Thanks to coal, we have the civilization that we do. We would not be able to be where we are today if it weren't for hundreds of years of people burning coal to drive machinery, for the Industrial Revolution, for all sorts of things. Fabulous. Where does coal come from? Well, take a look at this little animation. You get a bunch of plants, but this is from millions of years ago when dinosaurs were on the earth. Those plants will go and capture the energy of the sun, store it in molecules. When those plants die, they fall over. Other plants capture more energy and pile on top and pile on top. You can see pressure is building up, heat is building up. That pressure and that heat way underground form coal. This has millions of years of the sun's energy, and so this is a great fuel source because when you release it, you get lots of energy out. The problem, and the reason I say it's a double-sided coin, it also releases millions of years of carbon back into the atmosphere. We've been doing this for a couple of hundred years, and people are just now beginning to figure out that it's having some bad effects, like warming our entire atmosphere. But nevertheless, it's the same energy of the sun stored as molecules. And one other thing that I have here, I've got some oil, and natural gas is the same thing. When you have oil or natural gas, it's because there is a lot of plant and animal life that are storing the energy of the sun, that are floating in the seas. When they die, they fall to the bottom. They get covered up with mud. That mud presses down. More of them get covered up, presses down, and that pressure and that heat form oil and natural gas. This, once again, is a terrific energy source because we're getting millions of years of energy out, but we're also releasing millions of years of carbon dioxide and water vapor, both of which are greenhouse gases, into the atmosphere. So, I've talked here about lots of different ways to store energy that the Earth does. The energy of motion of the winds, the energy of height of raindrops which fall down and drive those hydroelectric plants, and the energy that's stored in molecules. It's up to the next generation of scientists, and maybe a lot of people who are in this audience, to figure out better and better ways to recapture all of those forms of energy and do it in a way that doesn't warm up the atmosphere. So are you guys up to the challenge? Yes, all right, that's what I heard. A lot of the younger people said yes, and that's what I love to hear. Well,
Thank
Alan,
you,
thank you for
That's
having
great.
me.
Thank you so much.
All right.
Just terrific. Just wonderful. Bravo.